Good morning, guys. Today we're going to be looking at properties of exponents. This will be part one. And so in working with exponents, there's certain rules that we need to look at. In Algebra 1, you may have worked with algebraic expressions that contain an exponent or exponents. And when you're working with these expressions, there's some properties, or you can call them rules, that we can follow to help simplify these expressions. One rule that we follow is called the product rule. If you have two exponential terms multiplying and they have the same base, the exponents end up adding. So there's a couple of terms that I'm talking about there. And so we call the x here, we would call it a base. And this power of a we call an exponent. And so we have another term here. It has a base and an exponent. So if we have two terms with the same base, in this case x, and they're multiplying, we have the product rule. Product means to multiply. When you have two terms like this, their exponents end up adding. Then you have what's called the power rule, is if you have an exponential term, but then you raise that term to another power, those two exponents multiply. And then the quotient rule, quotient means fraction. If you have two exponential terms with the same base, x and x, but they have different exponents, and they're dividing, one exponent is dividing the other, you can keep them with the same base and just subtract their exponents. So let's dive right in. Let's go to the first example, kind of get the ball rolling here, see what we're working with. So here there's multiplication going on. So it looks like we can say that this is looking like a product rule. And so what happens in a product rule is they have the same base, they both have an x, and so they would combine under one base, and you would add their exponents, so you get x to the fifth. Okay, so basically what's happening is, we can actually write x squared as x times x, right? And then we can write x to the third as x times x times x. And all these are multiplying. So you have x squared, which is made up of x times x. And then you have x to the third, which is made up of x times x times x. And so how many x's do we have, right? 1, 2, 3, 4, 5. So that's why we get x to the fifth power. We break it up that way. Then we go over here to the product rule. Oh, yeah, so this is the product rule because we have an not a product rule. We have an exponential. So this is actually called the power rule. We have an exponential. X to the fourth is being raised to the power of 3. So what happens is the 4 and the 3 exponents multiply. And so we end up with x to the power of 12. Okay. Let's look at example 3. This is a quotient rule. Situation. So we have x to the power of 7 divided by x to the 5th. Then we would write it as x to the power of 7 minus 5. You always subtract the larger minus the, not the larger. You subtract the top exponent minus the bottom exponent. So top minus bottom. And so that gives me 7 minus 5, that's 2, x squared. Okay, and so what we want to think of here, what's happening in example 3, is if you want to think of x to the power of 7 is the same thing as if I wrote x times x times x times x times x. 1, 2, 3, 4, 5, 6, 7. So if I multiply x 7 times, and then I'm going to divide this by x to the 5th. And so when we write x to the 5th, it's like if we're writing x times x times x times x times x. Okay, so I have 7 x's on top, 5 on the bottom, and then they're going to cancel out. Use a different color here. So for example, these two cancel out, these two cancel out, these two cancel out, these two cancel out, and these two cancel out. And so I'm left with x times x. But x times x is x squared. So what the quotient rule is doing is it's simplifying this whole process. It's simplifying the process. Instead of writing out, all these x's and all these x's down here, it's creating a simple rule to get the same type of answer. All right, so let's go to example 4. Okay, so here we have a quotient rule. Let me change the color here. We have what looks like a quotient rule because there's division happening. And so for this one, what we're going to do is we have x to the power of 5 on the top and x to the power of 7 on the bottom. And so remember what we said, it's like if we have x times x times x times x times x. We have 5 x's on top, and we're going to end up with 7 x's on the bottom. Okay, but what's going to happen is these 5 x's are going to cancel with these 5 x's. And I'm going to be left with, well, there's a 1 up here. There's still like a number up here. The number that's implied to be here is 1. So there's still a 1 up here. And we have 1 over what's x times x. That's x squared. And so this is our answer. So in a way, what we're doing is checking to see what's going to be left over. If I use the quotient rule, we would say, okay, they have the same base, and so we would subtract, so it's going to be 5 minus 7. So 5 minus 7 is negative 2. So we're getting a negative exponent. So these two answers are actually the same. These two answers are the same. But next class we're going to talk more about negative exponents. But for now, what we're going to say is, I know that when 5 and 7 subtract, it's going to give me 2. But we have to figure out and kind of see this and say, okay, I'm going to be left over with 2, but are they going to be left over on the top or on the bottom, right? On the top or on the bottom? Because I would see here, I have 7 on the bottom and 5 on top. That means I have more on the bottom than I do on the top. So whatever is going to be left over is going to be left over on the bottom. Okay. So let's look at example 5. Okay. And for this example, I like to kind of group like terms. What I mean by like terms is, I have a number, I have negative 3, I have 7. Those are same type of terms. I have an x squared and an x. And then I have y to the 4th and y to the 3rd. So they're multiplying. So we know that the numbers are going to multiply. So we're going to have negative 3 times 7. So this is like my number group, right? And then we're going to multiply the x groups. We have x squared times x. These are like my x's, right? And then I'm going to multiply y to the 4th times y to the 3rd. This is my y group. So this is what I mean by color coding, right? I'm figuring out which terms are the same type and then just multiply them. So what's negative 3 times 7? It's negative 21. What's x squared times x? Well, it's the same thing as writing x to the power of 2 plus 1 because there's a 1 right here. So 2 plus 1. And then times the y's. They're multiplying, so the exponents are going to add. So it's 4 plus 3. Right, and then one more, right? Bring down the negative 21. This is x to the power of 3 times y to the power of 7. That's my final answer. Okay, and let's see. And then if you're going to write it on Mastery Connect, you can also just type it like, without the multiplication. Something like this. So these two are the same thing. This doesn't have the multiplication symbol, this does, but here it's implied that everything's multiplying. All right, so let's look at example 6. So example 6 has a power rule. And so what's going to happen is, again, we're going to break this up into categories. We have the term that is a number, we have the term that's an x, and we have the term that is a y. But each one is going to be raised to the second power. So what it's going to look like is we're going to do the negative 11 is going to be raised to the second power times x to the power of 4 is going to be raised to the second power times y is going to be raised to the second power. So I have the number is raised to the second power, I have the x variable term is raised to the second power, and the y is raised to the second power. So again, kind of doing like a color coding thing and making sure that each term is raised to this power that was outside. Okay, so then we work it out and we ask ourselves, what's negative 11 times negative 11? That's positive 121 times, this is a power rule with the x's, so we're going to do x to the power of 4 times 2, and then times y squared. So bring down the 121, bring down the x, what's 4 times 2? It's 8, and bring down the y squared. All right, let's go back. Let's go over here to example 7. Right, so we're going to do this similar grouping thing again, where we group together the numbers, we group together the x terms, and we're going to group together the y terms. Okay, so if I look at the numbers, I have negative 9 divided by 27 times the variables x to the power of 11 divided by x to the 4th, and then times y divided by y to the 6th. And this y, since it doesn't have an exponent, is assumed to have a 1. So I have a 1, a 6, 11, and a 4. Here, I can say, can I simplify this fraction? Yeah, they're both divisible by 9. So we can simplify and we get negative 1/3. Right, 9 divided by 9 is 1. 27 divided by 9 is 3. Okay, then here we have the quotient rule, but are we going to have more x's on the top or more on the bottom? If I have 11 x's on top and 4 on the bottom, I'm going to cancel 4 of them. So what's 11 minus 4? It's like 11 minus 4. That's going to change to 11 minus 4 changes to a 7. And then for this one, for the y situation, I have 1 y on top and 6 on the bottom. So what's going to happen with the y's? Which section is going to have more y's? The bottom, right? Because there's 6 down here and 1 up here. So what's 1 minus 6? Or what's 6 minus 1? That's 5. But I'm going to be left with y to the fifth on the bottom and a 1 on top. Okay. So let me break it down again, right? We have 1y on top, 6 on the bottom. There's more on the bottom than on top, so I'm going to be left with 5 y's on the bottom and nothing on top except a 1. Right? Because it's assumed if there's nothing in front of the variable, it's assumed that there's a 1 in front. And so the y is going to cancel with 1y down here, and I'm going to be left with 5 y's. So if I multiply everything, also in this part, x to the power of 7, it's assumed to be a 1 down here. So if I multiply everything on top, what's negative 1 times x to the power of 7 times 1? That's negative x to the power of 7 divided by, what's 3 times 1? That's 3. 3 times y to the fifth is 3y to the fifth. Okay. All right, let's go to example 8. So we're going to do this grouping situation where we have a negative 6 and 3, kind of grouping the numbers together. There's also an x to the power of 4 just on the bottom. So there's a 1 here. And then what's going to happen with the y's? If I have y to the fifth and y to the seventh on the bottom. It's kind of like one of the examples we did earlier. I think it was example 3. No, it was actually, I think, example 4. But I'm going to solve each part. And again, for the x part, there's no x on the top. So what I'm saying is that there's kind of like a 1 in the top here. Okay. Another thing we can say is the following. We can write it this way, actually. We can say that we have negative 6 divided by 3x to the fourth. That can work as well. But the point I'm saying is that there's no x on top. There's only an x on the bottom. But the negative 6 and the 3, the negative 6 and the 3 can divide. What is negative 6 divided by 3? A negative 2 with an x to the fourth on the bottom. What's going to happen with the y's, right? What's 7 minus 5? That's 2. So there's going to be 2 y's left over, or y squared left over. But are they going to be left over on the top or on the bottom? It depends which part has more. Does the top have more y's or the bottom? The bottom has more y's, so we're going to end up with y squared on the bottom and a 1 on top. And so if we multiply across, what's negative 2 times 1? That's negative 2. And what's x to the 4th times y squared? Well, they can't multiply, so we just write them out separately. Okay, so we have the following. Okay. And so then let's go to example 9. Oh, example 9, sorry. Wasn't moving. Okay. Here I have, I have a 2, 2, 2, and then I have an x, and an x to the 3rd. Okay, so if I group them together, I have 2 times 2 times 2. This is like my red group. And then I have x times x times x to the 3rd. This is my green group, right? So what's 2 times 2 times 2? Becomes 8. X times x is x squared. So it's actually like I have x squared times x to the 3rd. But I can write it as x to the power of 2 plus 3, which is 8x to the power of 5. All right, let's go to example 10. Okay, so for this example, well, let me actually write it out again. Let me just copy it down here. And so what we're going to do is we're going to separate it, and we're going to say, okay, we have this part in front, and we have this part in the back. But we're going to just bring the 2x squared down, and the 3x to the 3rd, what's going to happen there is the 3 is going to be raised to the power of 3, and the x is going to be raised to the power of 3. So everything in here in the parentheses, the 3 is being raised to the power of 3, and the x is being raised to the power of 3. So again, I'm going to bring down the 2x squared times, what's 3 times 3 times 3? It's 27. And then x to the power of 3 is x to the 3rd. Right. Now I can combine numbers. I'm going to say what's 2 times 27? And what's x squared times x to the 3rd? 2 times 27 is 54. And x squared times x to the 3rd, 2 plus 3 is 5. If we want to group this, right, this became this, and then we kept solving, and this became this, and then we kind of group everything together. But I want to make sure that we know what's happening here in this green part is I'm raising 3 to the power of 3, and I'm raising x to the power of 3 to give me this result here. And then I'm combining this part with 2x squared, or multiplying it out. Okay, here we go. For 11, there's different ways to do it, but I think the easiest way is to simplify the inside and then raise everything to the power of 2. So let's simplify inside here, and so we're going to group the numbers. We're going to group the m's, and we're going to group the n's. Okay, so here we have 18 divided by 9. We have m to the third divided by m to the fourth. And then we have n squared, n to the third divided by n squared, and everything is raised to the power of 2. Okay. So let's simplify. 18 divided by 9. 18 divided by 9 is 2. And remember, if we have a whole number, it's assumed to have a 1 underneath. Then here, the m's are gonna divide. But remember, it's just kind of like canceling out. So, right, 3 minus 4, or 4 minus 3 is going to give us 1. But where is the m going to be left over? Should I put the m up here, or should I put it down here? Right, where should I put the m? Is the m going to be left over on the bottom or on the top? Because I have 3 on top and 4 on the bottom, so I have more m's on the bottom. So when they cancel out, I'm going to be left with 1 m on the bottom. And if there's nothing on top, it's assumed to be a 1. There's a 1 here. And then times, what happens with the n's? I have 3 on top and 2 on the bottom. I have more on the top. So as far as fractions go, there's going to be one n left over on top, and a 1 on the bottom. And it's going to be raised to the power of 2. And so we multiply everything. What's 2 times 1 times n? It's 2n. 2n on top. 2 times 1 times n is 2n. 1 times m times 1 is m. And it's raised to the power of 2. All right. Now what's going to happen next is, since it's raised to the power of 2, right, there was this power of 2 from the very beginning. So what's going to happen is each number and variable is going to be raised to the power of 2. So it's going to be 2 to the power of 2 times n to the power of 2 divided by m to the power of 2. So the 2 is being raised to the power of 2, the n is being raised to the power of 2, and the m is being raised to the power of 2. So that's going to give us 2 squared is 4. 2 times 2 is 4 times n squared divided by m squared. Right? So we have two more examples. Example 12. So here what we can do, it's totally up to you, but what I would suggest is simplifying the top, multiplying the top together, and then dividing the bottom afterwards. So if I multiply the top, I'm going to end up multiplying negative 5 times 4. Sorry, negative 5 times negative 4. And then I'm going to multiply a to the power of 9 times a. And then I'm going to end up multiplying b times b. And then copying everything on the bottom. Okay. So negative 5 times negative 4 is going to leave me with a positive 20. A to the 9th times a. 9 a's plus 1 more a is a to the power of 10. Times b is b squared. And then I'm just going to copy the bottom. So now we can divide out. What's 20 divided by negative 2? That's negative 10. And there seems to be a 1 underneath here. Or we can keep it, let's keep it like that. So it's negative 10. Then we have 10 a's on the top and 7 a's on the bottom. So 10 minus 7, because they're going to cancel. Right? Some a's are going to cancel on the top and on the bottom. So 10 minus 7 is going to leave you with a to the third on top. There's going to be more a's on top than on the bottom. So they're going to be left over on the top. And then I have 2 b's on the top and 5 on the bottom. So they're going to cancel out, and I'm going to be left with 5 minus 2. I'm going to be left with b to the third, or 3 b's. But those b's are going to be left on the bottom. Okay, so then I'm left with this final answer. All right, so again, what happened was 20 divided by negative 2 gave me negative 10. And I have this fraction here that I'm carrying over from over here, because there's a fraction division line here. 10 minus 7 is 3, but those 3 a's that are going to be left over are going to be left over on top, because there's more a's on the top than on the bottom. And then 5 minus 2 is 3, but there's more b's on the bottom, so there's going to be 3 b's left on the bottom. Then we have one more example. Example number 13. So if we combine the numbers together, we have 1/2 times 4 times a squared times a, combining the a's together, times c to the third times c squared. Okay. 1/2 times 4, what's half of 4? That's 2. A squared times a is a to the third, and c to the third times c squared is c to the power 5. All right, that concludes our notes for today. Thank you for joining me, and if you have any questions on any of the examples that we went over, you can bring them up in our class, and I can clarify anything that might have been confusing in the class session. Have a great day, guys.